run the stalling mechanism. So with tab, if you have a simulation, you have the possibility to read the hints, because there are hints in almost all the simulations. So English version of number 11, stalling mechanism. Do you remember? Yeah. So in this case you can just press left buttons because it will change the time resolution, and you have more heart cycles in the same time. And then you can, with escape, stop it. Then go down with the down arrow to data, press enter. You can choose from peripheral resistance or venous return. At first just increase the venous return. Look at the first, initially it was 90 milliliter. Check the stroke volume, it's the same, because these two are always the same. So if we increase it, for example 110, it will increase the stroke volume. Then we stop it with escape button, and we can see that ejection fraction is 55, so it's the same. Then we go down to data. Venous return should be changed to 120. It will increase it. The ejection fraction is almost the same. Then we change the venous return to 130. And we stop it. There is a really small change in the ejection fraction, actually. A really small. And you can tell that the venous return is higher because the end diastolic volume is also higher, and Frank stalling mechanism compensated for the changed venous return. That's easy, I think. And then we can make, for example, a table like venous return 90, 100, 110, 120, 30, and the EDV, SV, and ejection fraction. And you can discuss or show this way. And you can see that what I drew, I will give you this one. EDV, wall tension, stroke volume, you can see almost everything. Okay, then we should check peripheral resistance. For this, I set back the venous return to 90 and set the peripheral resistance to 125, for example. So after a run, you can see that ejection fraction is really, really high. But if we increase the peripheral resistance to, for example, 130, it will decrease the ejection fraction. Then 135 or 40 actually. You can see that the stroke volume initially decreases, then goes back to 90. Ejection fraction is now just 56. We started from 67. Then we stop it and increase further the peripheral resistance. Check the stroke volume. At first it will decrease, then it will be increased back to 90. Do you see? But the ejection fraction now is just 0.51. So it decreases when we increase the total peripheral resistance. And then we can set.
Well, why after the first increase the ejection fraction increased?
When? Because we set, actually these were not so realistic parameters when I started. I decreased the total peripheral resistance down to 125. It's really low. It's really low. But it's easy to demonstrate with this. So it increased from those parameters we ended the venous return setting. Okay, so the last is to set the peripheral resistance to 160, and the ejection fraction is 0.47. You tell the theory, you draw this really easy ratio and tell him that it actually decreased from 0.67 to to 0.47. In this case, it didn't change so much. It was just 0.56 to 0.53, almost nothing. But we increased the venous return from 90 till 130. So much increase. Okay, so actually this is this topic. The next one is quite similar. It says, do you have any question? Or would you like to check it? Or in the end, if you have time? Or next Friday you can do it on the last remedial one. Okay. They demonstrate the effect of altered peripheric resistance and altered venous return on cardiovascular shock. So you know what cardiovascular shock is, actually? You have to say this really nice definition.
Поза приступами.